Okay, so we're diving into the simulation hypothesis today.
Oh, wow.
Yeah, you send us just a ton of material on this.
Right.
Including, like, excerpts from physicist Sabine Hossenfelder's blog.
Oh, yeah, she's great.
And Nick Bostrom's original paper.
Ah, the classic.
So it seems like you really want to figure out, are we all just, bits in some cosmic computer program?
That's the big question, isn't it?
Right. It's kind of a mind-blowing concept.
Yeah, and it's been capturing imaginations for a while now. Even, big names like Elon Musk and Neil deGrasse Tyson have given it some serious thought.
Oh, wow. So it's not just like a fringe idea anymore.
Not at all.
So, like, where do we even start with something this massive?
Well, I guess the best place to begin is with the basic premise, right?
Okay.
The simulation hypothesis basically proposes that everything we experience, our reality, our consciousness, the whole shebang, could be a super advanced simulation created by, someone or something else.
So it's not just that it's possible, but that some people think it's actually likely.
That's where Nick Bostrom's famous trilemma comes in.
Oh, yeah, I've heard of that.
He doesn't actually say that we are in a simulation,
but
rather that one of three things must be true.
Okay, lay it on me.
All right, so first, civilizations might rarely reach the technological level needed to create such simulations.
So maybe we're just not advanced enough yet as a species.
Right. It could be a tech hurdle we haven't overcome.
Okay, that's one possibility.
Second, maybe civilizations that can reach that level choose not to for ethical or other reason.
So they have the power, but decide not to for whatever reason.
Yeah, maybe they've got their reasons,
Right. Ethics, boredom, maybe they found something better to do.
Exactly, who knows?
Yeah, who knows?
But, and this is the real mind bender.
Okay.
This third possibility is that if civilizations can reach that level of technology and do choose to run these simulations, then there would be so many simulated realities out there.
Oh, wow.
That statistically, it's way more likely that we are in one.
So it's a numbers game, kind of?
In a way, yes.
If simulations are common, we're probably in one?
That's the gist of it.
Okay, now I see why this whole thing is so fascinating.
Yeah, it makes you question everything.
Yeah, but how does Sabine Hossenfelder's take on this fit into all of this?
Right.
I mean, she doesn't seem to be debating whether or not these super advanced civilizations even exist.
That's what makes her perspective so interesting, I think. She comes at it from a purely scientific angle. She basically says, okay, let's assume those civilizations do exist.
Right.
But could they actually simulate a universe like ours?
Down to every last detail.
Exactly. Every quark, every photon, the whole shebang.
And based on what we know about physics, she's not buying it.
Not really, no.
So less about who's running the show and more about if the show can even be run in the first place.
That's a great way to put it.
So what's her main argument then?
Well, she argues that to create a convincing simulation, you wouldn't just need to replicate what we observe.
Okay.
But the actual laws of physics themselves.
The real deal.
Yeah, general relativity, the standard model of particle physics, all of that.
All that really complicated stuff.
Exactly. It's incredibly complex stuff.
Yeah, and she doesn't think you can just, think that. Right.
Well, she uses this great analogy with climate models.
Interesting.
You can't just ignore the tiny details in those models.
Right.
Because they have these ripple effects on the whole system.
So everything's connected.
Exactly. And she thinks the same would apply to a universe simulation.
So you have to get the fundamentals right.
You can't just cut corners.
And I remember her mentioning that physicists have actually looked for signs that our universe operates like a computer program.
Oh, they have, yeah.
But they haven't found anything, right?
Not a single shred of evidence.
Didn't she say something about Einstein being a real problem for the simulation hypothesis?
Oh, yeah. Einstein throws a major wrench into the whole thing.
Okay, how so?
Well, when physicists try to simulate our laws of physics, they often run into conflicts with Einstein's theories.
Right.
Which, have been tested and confirmed over and over again.
Right. So if we are in a simulation, the programmers would need to perfectly recreate Einsteinian physics.
And no one has figured out how to do that yet.
Okay, so that's one major hurdle for the simulation hypothesis.
It's a big one.
What about consciousness?
Ah, the big C.
I was thinking that simulating that might be like the ultimate challenge.
It's definitely a huge unknown.
But it seems like Hossenfelder doesn't completely rule it out.
Yeah, that's where things get more into the realm of philosophy. She acknowledges that we don't fully understand consciousness.
Right, still a big mystery.
A huge one. But she suggests that it could be the result of complex information processing. and whether that processing occurs in neurons or transistors.
So it might not matter so much what's doing the thinking.
Maybe not as much as we traditionally think.
So even if our brains are biological, if consciousness is all about information, maybe a powerful enough computer could replicate it.
That's the idea, but of course, we're deep into speculation territory here.
Right, of course. But even if we say, okay, let's say for a moment that consciousness could be simulated, there's still the mind-boggling question of simulating an entire universe.
Right. It's not a small feat.
With all of its information.
All those stars, planets, galaxies.
Yeah, it just seems like it would take like an insane amount of computing power.
It's a valid question, and it's something that Bostrom tackles head-on.
Okay, what does he say?
Well, he suggests that a simulation wouldn't necessarily need to simulate everything in perfect detail.
Like all the time?
Right, not constantly.
So it wouldn't need to be, like, constantly running at full resolution.
Exactly. He calls this sparse rendering.
Sparse rendering, okay, I like that.
The simulation could focus its processing power on the parts of the universe that are actually being observed.
Okay, so the parts that we're paying attention to.
And leave the rest in a simplified state or even dormant?
So kind of like those video games again, where they only render what you're currently looking at in high detail.
Exactly. That's a great analogy.
And everything else is just kind of blurry or filled in later if you need it.
Right, like a cosmic loading screen for the stuff we're not directly observing.
Whoa, that's a pretty trippy thought.
It is, isn't it? But remember, even video games have rules.
Right.
They can't just randomly change the laws of physics within their virtual worlds.
Yeah, that would be a pretty terrible game.
Right, it would break the immersion.
Which brings us right back to that problem of simulating the laws of physics in the first place.
Exactly, you can't just escape the fundamentals.
And I remember Hossenfelder making this point about the simulation hypothesis almost sounding like a religious belief.
Yeah, it's a key distinction that she makes.
So how does that work?
She argues that believing in the simulation hypothesis without a solid explanation for how it would work is essentially taking it on faith, not scientific logic.
So it's like saying, I believe it's true, even though I have no idea how it's possible.
Exactly. And, there's nothing wrong with having faith, but it's different from a scientific claim.
Right. Science requires explanations, evidence, testable predictions.
Precisely.
What about the argument that a simulation wouldn't need to simulate the fundamental physics?
Interesting point.
Just the observable outcomes, like the end results.
Oh, I see what you're getting at.
Wouldn't that be easier?
That's a common counterargument, and it seems plausible at first.
Right.
But it still runs into issues. Remember those climate models we talked about?
Oh, yeah, where everything is connected.
Right. Simulating just the surface level of reality wouldn't cut it.
I see. So you'd still need a ridiculously complex program running behind the scenes.
Exactly. You can't just conjure up a realistic universe without accounting for the underlying mechanisms.
Okay, so even if they were only showing us the end results, the program itself would still have to be mind-blowingly complicated.
To make it all work consistently, absolutely.
Okay, that makes a lot of sense. So where does this all leave us with the simulation hypothesis then?
Well, it's still a fascinating idea.
It is.
But as Hossenfelder points out, based on what we currently understand about physics,
right,
it seems incredibly unlikely. Simulating a universe as intricate as ours, with all its laws and complexities, appears incredibly difficult.
It does, yeah.
If not impossible.
It's starting to sound like trying to build a skyscraper out of toothpicks.
Haha, a very fitting analogy.
But hey, science is always evolving, right?
Absolutely, that's the beauty of it.
Who knows, maybe there are aspects of physics we haven't even discovered yet that could change the whole game.
That's what keeps things interesting, isn't it?
It does, because even if the current evidence suggests it's unlikely, it still opens up all of these amazing what-if questions.
Right.
About the very nature of reality.
Exactly, and those questions are worth exploring.
For sure. Now, you also sent us some excerpts from Nick Bostrom's original paper.
Oh, yes, his seminal work.
Where he really lays out his argument in detail.
He goes deep into the weeds.
So, shall we dive into that now?
Let's do it.
All right, so we've talked about the challenges of actually, simulating a universe like ours.
Yeah, the sheer scale of it.
But let's dig a little deeper into Nick Bostrom's ideas. You mentioned something called substrate independence earlier.
Ah, yes.
I have to admit that one kind of went over my head.
It's a bit of a head scratcher.
Can we unpack that a little bit? What does that even mean?
Sure, it's a pretty dense concept, but it's super important to Bostrom's argument.
Okay.
So imagine a computer program, like say a video game.
Okay.
The program itself is basically a set of instructions, right?
Right, the code.
but it can run on different types of hardware.
Yeah, like my game runs on PC and my friend plays it on their console.
Exactly. A PC, a console, even a smartphone these days.
So same game, different machines.
That's the idea.
Got it.
Substrate independence is kind of similar, but applied to consciousness.
Okay, now we're getting interesting.
It suggests that consciousness, like the experience of being you, isn't necessarily tied to the specific physical material of our brains.
Oh, okay, so our brains are like the hardware and consciousness is like the software.
That's a good way to think about it.
And that software could potentially run on like something else.
Precisely. It's like saying that the essence of your thoughts and feelings and experiences could potentially exist on a different physical platform.
Wow, that's kind of blowing my mind a little bit, but is there any real-world evidence to suggest that this is even possible?
Well, it's still early days, but there's a field called neuroprosthetics.
Neuroprosthetics, okay.
Where researchers are developing brain-computer interfaces.
Oh, yeah, I've heard of those.
And some of these interfaces are already allowing people with paralysis to control robotic limbs just by thinking.
Seriously, just by thinking?
Yep, they can imagine moving their hand.
Whoa.
And the robotic hand moves.
That's insane. So we're already starting to blur the lines between like brains and computers?
In a way, yes.
Huh. Okay, so how does all of this tie back into the simulation hypothesis?
Well, Bostrom takes this idea of substrate independence and he runs with it.
Okay.
He argues that if consciousness is ultimately about information processing, it might not matter whether those processes are happening in neurons or in transistors.
Okay, so it's the information that matters, not the physical stuff.
Right. The medium might be less important than we think.
So a super advanced computer could theoretically host a conscious mind.
That's the idea. And if you can simulate a mind, why not simulate an entire world for that mind to experience?
Okay, so it's not just about simulating a brain in a jar.
Right.
It's like simulating a brain in a whole simulated universe.
Exactly. It's like creating a custom virtual reality for every simulated mind.
That is a wild thought, and he actually thinks that civilizations would do this.
He proposes that advanced civilizations might run countless ancestor simulations.
The ancestor simulation.
Yeah, essentially recreating their own evolutionary history in a digital environment.
So like reliving their past?
In a way, yes.
But digitally.
Imagine like historical reenactments, but on a cosmic scale.
That's a lot to wrap my head around, but hold on. This brings us back to, those massive computational challenges.
Right, the processing power.
We talked about earlier.
Yeah.
Wouldn't simulating an entire universe, even like a simplified one, require just unimaginable computing power? How could they possibly manage that?
You're hitting on a crucial point, and Bostrom addresses this head on.
Okay, I'm all ears.
He suggests that a truly advanced simulation wouldn't need to render every single detail of the universe all at once. It could focus its resources on what's currently being observed.
Right, like what we're actually looking at.
Exactly, and leave the rest in a simpler state, or even dormant.
So, like, if I'm not looking at a particular galaxy, the simulation doesn't need to bother with all the stars and planets there.
Precisely. It can just fill in the blanks.
Okay, so it only renders what we're paying attention to.
That's the gist of it.
And then, like, fills in the rest if we decide to look in that direction.
It's like having a massive detailed map, but you only unfold the sections you need at any given moment.
Okay, that's a pretty cool way to think about it.
And he even suggests that the level of detail could adjust dynamically.
Dynamically, what does that mean?
Based on how closely something is being observed.
Okay, so if I'm looking at a distant galaxy through a high-powered telescope,
all right,
the simulation might render it in more detail than if I was just glancing at it with the naked eye.
Exactly. The closer you look, the more detail emerges.
That's pretty clever.
It would allow a simulation to manage the vast amount of information in a universe without needing infinite computing power.
Okay, so they're basically like optimizing the processing power.
Being very efficient with their resources.
But wouldn't a system like that, wouldn't that be incredibly complex to manage?
It would be a huge challenge for sure.
What about consistency? Wouldn't there be like glitches or errors if the simulation is constantly adjusting things based on our observations?
That's a very valid concern, and it's a point that Hassenfelder brings up in her critique. She argues that even with this sparse rendering, a simulation would still need to adhere to the fundamental laws of physics.
So they can't just like break the rules whenever they want.
If the simulation starts taking shortcuts or bending the rules, it would likely create discrepancies that we could observe.
Yeah, it would be like a video game that suddenly decides to ignore gravity.
Right. or let you walk through walls.
Exactly. It would break the illusion.
And because our current understanding of physics suggests those laws are incredibly precise and interconnected,
Yeah.
Hassenfelder believes it would be very difficult for a simulation to fudge them without us noticing.
So even if they're only showing us what we're looking at, they can't just cheat on the underlying physics.
It would be incredibly difficult to maintain consistency without adhering to those fundamental laws.
Bostrom must have thought about this too, right?
Yeah.
What does he say about that?
He does acknowledge that maintaining consistency would be a major challenge for any simulated universe. And he even suggests that a truly advanced simulation might be able to predict what its inhabitants are going to observe.
Whoa, hold on. Predict what we're going to look at.
And pre-render those parts of the universe in advance.
So it's like the simulation is playing a cosmic game of chess, always like thinking a few moves ahead.
That's one way to think about it.
Anticipating our observations and making sure everything's consistent.
Trying to stay one step ahead.
But even if a simulation could do all that, there's still the question of how it would simulate the laws of physics themselves.
Right, the underlying framework.
And didn't Hassenfelder say that that's like the biggest obstacle for the simulation hypothesis?
Absolutely. We haven't found any evidence that our universe operates like a computer program.
Right, it's like searching for the source code of reality.
And coming up empty-handed.
And even if there is some kind of underlying code governing our universe, who's to say it would resemble anything that we recognize as computer code?
That's a great point. Maybe the programmers of our simulation are using some incredibly advanced technology or principles that we haven't even imagined yet.
It's definitely a possibility.
The possibilities are endless when you start thinking about it.
But without any evidence, it's all just speculation at this point.
That's the nature of exploring the unknown.
Okay, so we've really gone deep on this whole simulation hypothesis thing.
Yeah, we've explored a lot of different angles.
But you know, I can't help but wonder, if we are in a simulation, wouldn't there be like some clues, like glitches in the matrix?
It's a natural question to ask, and some scientists have suggested that there might be subtle signs we could look for.
Okay, like what kind of signs?
Well, one idea is that if the simulation uses a finite number of bits to represent information...
Right, like a limited amount of data.
Exactly. Those limitations might show up in our measurements.
In our measurements of what?
Things like physical constants, or maybe in the behavior of cosmic rays.
Oh, I see. So, like, if the resolution of the simulation is an infinite, we might be able to detect those pixels, so to speak.
That's the idea. But so far, none of these proposed signatures have been definitively observed.
So no smoking gun yet?
Not yet. And it's also worth considering that a really advanced simulation might be able to, like, patch any glitches.
Oh, interesting.
Or even prevent us from finding evidence of its existence altogether.
So it's like we're trying to outsmart a hacker who's always a step ahead.
It's kind of a mind-boggling thought, isn't it?
It really is. Like, we might never be able to definitively prove it, even if it were true.
That's the paradox. We could be living in a simulation and never know for sure.
It's like being in that locked room, never knowing for sure what's outside.
Exactly. The mystery remains.
Okay, so after all this discussion, where do we land on the simulation hypothesis? Is it a scientific theory?
Well, not in the traditional sense. It's more of a thought experiment, a philosophical exploration.
Right, like a way to stretch our imaginations.
Exactly. It encourages us to think outside the box, to question our assumptions about reality.
And, you know, I think one of the reasons why the simulation hypothesis is so captivating is because it kind of fits in with our current technological landscape.
I agree. We're surrounded by virtual worlds, simulations, video games.
It's not that hard to imagine that our reality could be just one giant simulation, right?
It's a very modern myth, in a way.
Yeah, and I think it also taps into that, like, human desire to believe that there's more to reality than meets the eye.
Absolutely. That sense of wonder, the possibility of hidden layers.
Right. Those glitch in the matrix moments that make you question everything.
We've all had those moments, haven't we?
Yeah, totally. But I guess the key takeaway here is that just because something is intriguing or feels right doesn't necessarily make it true.
That's where critical thinking comes in. We can explore these ideas, but we also need to examine them carefully.
And hold them up to a certain standard of evidence.
Exactly. Extraordinary claims require extraordinary evidence, as they say.
And so far, the evidence for the simulation hypothesis is, well, pretty thin.
We haven't found that undeniable proof yet.
But hey, maybe someday we will.
Who knows what the future holds?
Or maybe the programmers will decide to reveal themselves.
Now that would be a twist.
It would. One last thing that really struck me from Hassenfelder's blog was her point about the difference between religious claims and scientific ones.
Oh, that's an important distinction. She argues that religious beliefs often rely on faith and acceptance without concrete evidence.
Right, like taking things on faith.
While science, on the other hand, is all about explanations, testable predictions.
Right, it's a different way of knowing.
Exactly, a different framework.
So believing in the simulation hypothesis without any explanation for how it would actually work, that's more like a faith-based belief than a scientific hypothesis.
That's essentially what Hassenfelder is getting at.
And there's nothing wrong with that.
Of course not.
But it's important to be clear about what kind of framework we're using to understand these ideas.
I couldn't agree more. Clarity is key.
So ultimately, the simulation hypothesis, while super interesting, just doesn't quite meet that bar of scientific rigor.
At least not yet. But, even though we haven't arrived at any definitive answers, I think this whole exploration has been incredibly valuable.
I agree.
It's stretched our imaginations. It's made us think about the nature of reality in new ways.
It's like we've taken a mental journey through the cosmos,
exploring all these different possibilities.
And come back with a fresh perspective on our own existence.
That's what these deep dives are all about, expanding our horizons, challenging our assumptions.
And igniting that sense of curiosity about the world around us.
Exactly. And even if we aren't living in a simulation, which seems to be the most likely scenario,
probably,
this whole exploration has been anything but a waste of time.
It's been a wild ride.
A true intellectual adventure.
And for you, dear listener, we hope this deep dive has been both enlightening and entertaining.
We hope you've enjoyed the journey.
Keep questioning, keep exploring, and as always, happy thinking.